Hey guys, this is your first video for Unit 7 called Natural Events, but really and truly I like to think of it as plate tectonics. So we've been talking about what's happening on the Earth's surface in terms of ocean and then also what's in the atmosphere. This unit, we're going to focus on the surface, but not the ocean part, but the land part, and then we're going to go deep down underneath to see what's going on. The title of this video is Theory of Continental Drift, and we're going to figure out what that has to do with us. But first, let's take a look at how the Earth is ordered on the inside. This is a cross-section of the Earth from the outside towards the inside, and we have individual layers. Now, each one of these layers has individual characteristics based off of density, temperature, and pressure, and that's what decides which layer it is and where it's located. We start with the crust and we work our way towards the inner core. The crust is going to have much less pressure and a good temperature for life to happen. And as we go through the individual layers, we're going to find that temperature is dramatically going to increase. The pressure is also dramatically going to increase as we go from crust to inner core. And the third characteristic is density. That determines which layer is on top of which layer. The crust is much less dense, so it's on top of the mantle. The mantle is less dense than the outer core, and the outer core is less dense than the inner core. So our interior is ordered by temperature, pressure, and density. So we're going to start this unit really talking about and focusing on a gentleman by the name of Alfred Wagner. And Wagner, born in Germany, really liked to study not the Earth as in terms of land and rocks, but he liked the meteorology piece, which is what we just finished. Wagner was a big fan of books and libraries and liked to do lots of research. And so let me show you a picture. This is Alfred Wagner. He lived from the late 1800s to the mid-1900s, so he has only been gone for a few short decades. And this gentleman gave lots of contributions to meteorology. One day he was in the library and he figured something out just from looking at some maps. So he was looking at some particular maps, and this one happens to be very similar to the one he was looking at, where it showed the mountain ranges and the shapes of the continents really well. And Wagner really started to focus on that each of these continents or land masses looked like puzzle pieces. They look like they should fit together, and that some of their mountain ranges look like they had just been ripped apart and separated by these oceans. So he started asking questions and doing some further research. Wagner used something called empirical evidence, or a way of gaining knowledge by means of direct or indirect observations. Wagner made some direct observations by being up in hot air balloons and looking straight down, and at the same time he used maps and he used other people's observations together. Empirical evidence can be analyzed quantitatively, so dealing with numbers, or quantitatively, dealing with description. And we use empirical evidence to prove a scientific explanation. So Wagner really wanted to explain why the Earth's surface looked the way that it did, why the continents were shaped the way that they were, and how did they possibly get there. So in the 1920s, Wagner published his theory, and we call this the theory of continental drift. Wagner used empirical evidence, and you'll see the four major topics or concepts. First of all, he used the evidence from the map that the shape of the continents seemed to fit together like puzzle pieces, specifically focusing on South America and Africa, and how the west coast of Africa seemed to fit right on top of the east coast of South America. Wagner also used the rock types and how we were able to find particular rock samples in North America that matched exactly with the samples that are in Europe. And there's no way that could happen unless those land masses were close together. Wagner also used plant and animal fossils, specifically the plant Glossopteris and the animal Mesosaurus. And where they were located had to have been touching. They could not have gone from one place to another. And the last and final piece of evidence was the glacial markings, or evidence of climate change. And sadly, Wagner was not accepted as a wide theory because he couldn't say how.